Okay, step number 1 will be to draw a diagram that represents information in the question. So we're always going to start with our true north, and then we're looking at the vessel was on a course of 30 degrees true. Now this is just a sketch, you don't need to use a protractor. So 30 degrees true is going out this way. So the vessel is traveling in that direction along that line, and this angle in here is the 30 degrees true. Now the next thing is 11:30. The navigator sights a lighthouse on a bearing of 95 degrees true. So 95 degrees true is down this way. I'll draw a solid line. Now that's a little bit more than 95 degrees, but that's all right. So that's our lighthouse down there, lighthouse L. Now the boat continues to travel along until the angle at the bow has doubled. So the first thing we need to do is work out what the angle at the bow is. So this angle in here was 95, and this angle from here to the boat is 35. Then the angle from the bow of the boat, remember the boat's facing that way, so the angle from the bow of the boat here to where the lighthouse is 65. Now the boat's going to continue along this path until the angle from the front of the boat, the bow of the boat, to the lighthouse has doubled. Now I'm just going to make it here. Diagram is not to scale, okay, and this angle has doubled, so 130. So this was 65, the angle from the front of the boat to the lighthouse, and now this angle here is from the front of the boat to the lighthouse has doubled, 130. Now what we have is an isosceles triangle. So if you remember, an isosceles triangle has the two angles down the bottom the same and the two sides are the same. So the angle on the outside of the triangle is equal to the sum of the angles on the inside of the triangle. So that makes this 65. 65 plus 65 is 130. Alternatively, you could have worked out that this angle here was 50 because of the 180 on a straight line, and then worked this out as being 65. Now this is our isosceles triangle. Again, it's not to scale, but this is what we're working with, which makes these two sides the same. So what we want to know is how far away from the lighthouse we are, but we know this distance here is how far we traveled in a set time. So the time was 11:30 to 12:20. Okay, that's 50 minutes. The speed that we were traveling at was 16 knots. And then we know that distance is speed times time. So our speed was 16, our time was 50 minutes, remember 11:30 to 12:20, but we need our time in hours. So we're going to multiply by 50 minutes and we're going to divide that by 60 to turn this into hours. And then we have our answer of 13.3 recurring nautical miles. And that's the distance that we traveled during that time. It's also now the distance that we are from the lighthouse because we created an isosceles triangle which had the equal angles at the bottom and the two equal sides. And that is how you fix your position using doubling the angle of the bow.